Hello people, right, here's a starter question for you. A curve has that equation. At point A, the coordinates are 2 minus 16. At point B, the x coordinate is 2 plus h. You need to find the y coordinate. You do that by subbing it into the equation x to the 3 take 12. Part A of this question says show that the gradient of the line A to B is 6 plus h squared. Remember, gradient is the changing y over the changing x. And then part B, explain how the resulting part A can be used to show that A is a stationary point on a curve. Now, if it's a stationary point on a curve, remember, we're talking about, well, we don't know yet. It's not talking about stationary points. But when I'm talking about stationary points, you might remember from mechanics. That means that the gradient is at the top here, or the gradient is at the bottom of something. And when that gradient is at the top or the bottom, the gradient is, maybe you've answered that or not. Let's pause this video and have a go, please. Right, we've unpaused now. So hopefully I've managed to do that. Sorry, my cat's just knocked something off. So there's the answers to part A. How you did it, changing y over changing x. So it was all about that thing without the limit thing on. You could put the limit thing on if you wanted, but changing y was that bit. Take the 16, take the negative 16 over that, and it reduced. And if you put the limit things round it here as h tends to 0, all of this would turn to 0. So what we're saying is that as those 2 points get closer and closer together on the curve at the point 2 minus 16, they're actually giving a gradient of 0. If it's a gradient of 0, this line has no slope, therefore it's a maximum or a minimum point, i.e. a stationary point. Hopefully that was okay. Right, today's lesson, differentiation 4. If you've printed out the student slide to go with it, that's good. There's no worksheet for this lesson. It will be some questions from the textbook. Right, we've got to be able to find stationary points today on a curve, but you'll be pleased to hear we're not using differentiation from first principles to do this. We're using our rule of differentiation, which, if you remember, dy dx, if y equals x to the n, the rule is dy dx equals nx to the n minus 1. We're going back to that. We're going to be using it to find stationary points and then deciding whether they are maximum or minimum points. And then we're going to be able to use our calculator to find stationary points as well. So a stationary point occurs when the gradient of the curve is 0. So we can't show you here, but here with the gradient will be negative, and then it's going to positive. So here it's, well, let me draw on there, but it's negative, and then it's going to positive. So if it goes from negative to positive, that is a minimum. And if your gradient goes from positive to negative, stops for a second at the top there, where the gradient is 0, and that's a maximum. Differentiating a function y equals f of x gives us the derivative dy dx or f dash of x. Differentiating a function a second time gives us what's called the second order derivative. This can be written as d2y by dx squared. or in fact f dash dash of x. The second order derivative gives us the rate of change of the gradient of the function. We can think of this as the gradient of the gradient. The second order derivative can often be used to decide whether a point is maximum or minimum. Now I'll explain this in a minute, but if d2y is less than 0, then the point is a maximum. And if d2y by dx squared is greater than 0, then it's a minimum. And if d2y by dx squared is 0, we cannot make any conclusion about the stationary point, and we look at what we do about with this next year, so not in the AS course. Right, I said I'd explain that. So if you had a maximum to stationary point, we're looking at something like that, aren't we? And if you had a minimum stationary point, we're looking at the graph of being on an axis. We're looking at the graph being a minimum. So it might be something like there's an axis there, it's a minimum. We can see that. I wanted to look at the gradients. If we looked at that's y against x. If we looked at dy against x, dy dx against x. So we're looking at plotting the gradient here. Well, if we go along the curve, it's a steep positive, so it's a big positive, a big positive, a big positive until it's 0. So, sorry, that's a lie again. That's a big positive, a steep positive. It's less steep, less steep until it's 0. So it's going like this. It's still, this is positive up here. And positive, 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 positive until it hits the stationary point when it's 0. So it's 0 at the top. And then it's going negative, but less negative, more steep negative, steep negative, steep negative, something like that. With this one, try and line it up this time. It's steep negative, big negative, still negative, but less negative. The gradient at the bottom there is 0. So negative, 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 and then it starts getting positive, but not too positive, not too big a slope, but steeper, 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 steeper. So this one's going the opposite way. So until you get to the stationary point where it's 0, it's negative, and then it starts becoming more and more positive. So it's actually a straight line, is that? And that's plotting dy dx. That's plotting the gradient against x. Now, if we were to plot d2y by dx squared, that's differentiating again. We're to plot that against x, we can see that this line has a negative gradient all the time. So it's actually down here. So it's a straight line, a negative one. All the time. This one, it's a positive gradient, gradient of 2. It stays positive all the time. It's not varying. That's a straight line. No, it doesn't look particularly like a straight line, but it's always positive. That's always positive. So here we have d2y by dx squared. It's positive, and it means we had a minimum curve to start with. And if d2y here is negative, that means we had a maximum curve to start with. Hopefully it makes a bit more sense what those y is. If it's d2y by dx squared is negative, then it was a maximum. d2y by dx squared is positive, then it's a minimum. That needs remembering. So let's have a go at the question. Find the coordinates of the stationary point on the curve with this thing and state its nature. So we start off dy dx, well that would be, me chance to think. That's 3x squared take 12. I thought that's what you said. To find a stationary point, that's when the gradient is 0. So you're at your maximum, you're at your minimum, you're at where the gradient is 0. So we let that equal 0. Might want to factorise out 3 or divide through by 3. In fact, let's divide through by 3 and get rid of it. So we've got 0 divided by 3 is 0. That becomes x squared and that becomes minus 4. And then you might recognise that as the difference between two squares. Hopefully you've said it by now. Plus 2 x minus 2. Oops. So what that means is there's two solutions to this. X can either equal, to make this true, x can either equal minus 2 or 2. So we've got two options. So in other words, there's going to be two stationary points. There's going to be one and another. So at x equals 2, we take them separately. At x equals 2, let's find out the y coordinate for that stationary point. So when x equals 2, the y will be, putting 2 into the equation, that's 2 to the power 3 minus 12 times 2, which is 24, and add 7. That's 8. Take 24 with minus 16, add 7. Hopefully that's minus 9 without giving things out. I think I'm on that. Minus 9, so that's 2 minus 9. That's one coordinate of the stationary point. The other coordinate, I put minus 2 into there. So that will be minus 2 to the power 3 is minus 8. Add 24 this time and add 7. Right, what's that become? So that's 16. 16 add 7 is 23. So that's the coordinate minus 2, 23. So I know I've got two stationary points. I've got one and I've got another. Maybe one's a max, one's a min. I've got to find out which one's which. So on we go. So to find out which one's which, you need to differentiate again. Now we've just said dy dx was 3x squared minus 12, wasn't it? If we differentiate that again, what we'll end up getting is 6x. No, constant disappears. Right, to find out at each point what's going on, well, when we had x was 2, that was one of the stationary points. If I sub 2 into there, 6 times 2, I get 12. As we described before, if that's positive, you have to remember, then we've got a minimum. So it was a min at the point 2 minus 9. And when x is a negative, we'd have 6 times negative 2, which is minus 24. So your d2y by dx squared is negative, so that's a max at the point minus 2, and the point was, I think it was 23. Okay. That made sense. If we wanted to see that on the calculator, it will be a lot to follow here. So we need to go into graph mode. So I'll write that down if you're following. Graph mode on the calculator. When you've pressed that, clear any graphs that are in there, and you can do that hopefully by pressing delete, which is on the F2 key. So delete anything you've got hanging around in there. If you've got anything on it, you have to press delete and then F1 to get rid of it. And when you've got nothing in there, what you want you to type is this equation here. You don't need to put y equals, you just need to put x to the power 3. Now you need to do that with the x theta t button. So that button you need to press to get up the x. And then to power 3, you have to press that hat button. And that gives you power 3. And then you have to put a 3 in, of course. So type that in. And then subtract 12x and then add 7. So obviously the keys we would put in is minus 12, another x theta t button, and then add 7. So once you've got that graph in, oops, and sometimes when you're on that power you have to get off the power. Just as a note, when you've just put that in, you might have to press the cursor key in there. I mean cursor key, I'm on about like the arrow type thing, just to get yourself off the power, and then you can put subtract 12 x theta t plus 7. And when you've got that in, you can either press F6 for draw or press the EXE. I have to press EXE twice. I've got my graph, it's a bit of it's off the graph, so it might not matter. I think it does actually. So I'll just try without doing anything. Right, so if I press what's called G solve, which is F5 key, I get options for max and min. The max is on the F2 button and the min's on the F3 button. If you press maximum, hopefully it should come up at the bottom of it saying x equals, no, sorry, actually, x equals minus 2, y equals 23, which agreed with what we did before. And if you then exit, so press the exit button, that's always a good button to press. And then try pressing, oh, it's gone again, so I have to press G solve, the F5 again. Oops. Oh, I might have to draw it again, sorry. Draw the picture again, and I've gone back to the equation. And then press G solve, and then press F3 for minimum. It should come up with x equals 2 and y equals minus 9. Just confirming what we did was correct, and you should be seeing this sort of picture. No, it doesn't do that. I'll tell you, don't do that. Yeah, that's it, like that. So the max and minimum, there's one at 2 and there's one at minus 2. 2, that's it. And the y coordinate obviously there is minus 9, and the thing on there, it's gone off my screen as that one, but that one was a 23. Okay, hope you managed that with your calculator too. You might want to rewind and start again. That slide again if you haven't got your calculator out your bag. Right. Example 2. Just do it again, basically. This time find dy dx and d2y by dx squared. Then find the coordinates of any stationary points and determine their nature. I've got one on the slide. Okay, now you have to come up. Right, dy dx then, we differentiate that. Just give you a second, you write down what you think it is. Okay, what we should have is 3x squared minus 12x take 15. Differentiate it again. That would give us 6x take 12. So done part A. Find the coordinates of any stationary point on the curve and determine their nature. Remember, stationary points occur when the gradient of the graph is 0. That's what means stationary, going nowhere. So dy by dx equal to 0. So we set our dy dx equal to 0. Try and solve it. Well, it's one to put in your calculator, perhaps this one. If you put that in as a polynomial, so if you go to menu, equation mode, you put it in as a poly with degree 2, we've done plenty of these, put in the things 3, minus 12 and minus 15, it should tell you the answers. It tells me the answers anyway. It tells me the answers are 5 and minus 1. If I wanted to bracket that, how that's come about, which would be a bit strange. It's come about from one's 3x and one's x if you were guessing. And you've got to make 15. 15 was in there and it was a 1 in the other one. And oh no, it wasn't. That's a lie. I'm doing that wrong. Whoops a daisy. Whoops a daisy. Whoops a daisy. Get the rubber out. No, don't copy that. It was, and I'll show you, you don't really need to write this, but it was. There was plus 3 and there was minus 5. You can check it if you want. Minus 15, 3x squared, a 3x and a 3 times 5, and minus 15x, minus 15, add 3 is minus 12. But solving that gives you x equals minus 1. And solving that bracket would give you x equals 5. So that's what the calculator's told you if you use equations mode. Don't need that middle step unless you want to write it. Nice to write it. But there we go. Right, so we've got two options. X is minus, we've got two stationary points. One when x is minus 1 and one when x is 5. So find the y coordinate. So there was the y equation here. It's original curve. Put minus 1 in there. Minus 1 to the power 3. Add 6 lots of minus 1 squared. Take away 15 times minus 1. If you type that into your machine or you want to work it out, that'll be minus 1, add 6, which is 5, and 5, but add 5, add 15 is 20. So that's giving me the stationary point, minus 1, 20. To find out whether that's a max or a minimum, I need to consider that d2y by dx squared. Well, that's up here. Remember we said that was 6x take 12 from part A. Okay, right, we're going to put in our minus 1 in where there's an x. So that's 6 lots of minus 1, take away 12. Well, that gives us negative 18. So it's a negative. That tells me this is a max point at that there. When the other coordinate probably be a minimum, we best check it. When x is 5, what's the y? Oh, it's a bit nasty. I need your calculator now. 5 to the power 3, take away 6 lots of 5 squared. Take 15 lots of 5, stick that in the machine. Comes out at minus 100. Hope you got that too. So we know the stationary point is at 5, negative 100. Find out if it's a max or a minimum. We sub our 5 into the d2y by dx equation, which is 6 lots of 5. Take 12. Oh, that will be 30. Take 12, which is 18, and it's a positive 18, therefore it's a min at that point. If we were looking at that curve, you could put that in your calculator. So if you want to jot that one into the calculator, so again, go back to graph mode, pop in x theta t to the power 3, move the cursor key to get the arrow down off the power, subtract 6 x theta t to get your x squared, and then take 15x theta t, and look at that graph. It should look a bit like the one we're about to. Just before I move on, you might notice I made a mistake there. Copied that wrong there. Copying it from here. So it was x squared minus. So I made a mistake there. So that was minus 1. Yes, take 6 and then add 15. That actually makes 8, doesn't it? Sorry, it's a delayed reaction there, 8. So that was rubbish there. Sorry. Hope you didn't do that in your notes. Well done if you spotted that little error. Right, going on to look at the graph here then. So if you put this in your calculator, so remember you're pressing the x theta t button when you want an x, and that's power, so you have to use that 3. And then you have to press the little cursor to bring it back down, and then minus, and so on. Right, what you should get when you do that, so you're in graph mode and you've done that, get a curve that looks a bit like this. It goes through the 0, 0. And it goes down probably way off your, way down there, but it's a bit of a sketch, not a proper graph. So it's got a maximum at minus 1/8 and a minimum at 5 minus 100. Lovely. So summary of steps to find out max and minimums, called stationary points. First you find an expression for dy dx, and then you know it's a stationary point when dy dx is 0. So you solve that, you might get a couple of values of x, you might get 3 values of x, or maybe just 1 value of x for that. But for each value of x, you have to find the stationary point. You also have to calculate the y value by sticking it back in the original expression of function here. And then to find its max and min, you need to work out d2y by dx squared, in other words, differentiate your dy dx. And then if it's greater than 0, it's a minimum. If it's less than 0, when you put your value of x in, then it's a maximum. So here's a whiteboard question I'd like you to try. Please pause this now, have a go, and unpause when you're ready. So now we're on unpause, and here come answers. Oh, I've got that wrong when I did that one. 3 minus 62 d2y by dx squared was 30, so it's a minimum. And the other one, minus 263, and d2y by dx squared was negative 30, and that one was a maximum. Hope you got that right. You may not have done the bracketing, you might have just put that straight in your calculator here. You can solve that in your calculator if you wish and get the straight to the x is 3 and x is minus 2. But solving it obviously equal to 0. Right. Some more for you just to have a quick go at. So try these on the whiteboards or your paper or your walls if your parents allowed, which you don't. Find the coordinates of the stationary points for each of the following functions and determine the nature of those things. So basically find me d2y by dx squared to see if it's a max or a min. But first job is dy dx and equal it to 0. So same for these questions, off you go. And when you're ready, unpause the video. So pause it now. Okay, we're on unpause, and here come the answers. She says. And the second one. Hope you manage them. Hope you can learn to check them with your calculator by doing the graph and then pressing G-solve. And hope you have some success. What you have to do when you've done that is, there's a good exercise from the book. Make this up to an hour and a half's work. So it's questions 1 to 7 from exercise 13B of the textbook. Please have a go at some of them, and don't just spend whatever time you need to spend on that. I think my lesson's only going to be about 30 odd minutes, but I know you've had pauses, so it may be 3/4 of an hour. So you might be we have at least got another, I'd say got a half an hour to have a go at those 1 to 7. See how many you can get done in half an hour, and then that will be fine. Okay then, right, see you soon, bye.